Moving into the next problem set from section 6.1. This is similar to some of the formulas that we were factoring in class this past week. In this particular problem set, you are asked to solve each equation for x. So you're just trying to isolate the x. Number 30 is a problem from the book, and you can see I have ax plus bx already arranged together on the same side of the equal sign, and it's set equal to this trinomial. The trinomial on the right-hand side factors as a plus b times a plus b. And when I remove the common x using the reverse distributive property on the left-hand side of the equal sign, I can see that I'm left with x times the binomial a plus b. So this is all done in an effort to isolate the x. So the first step is using the reverse distributive property so that the x only appears one time as a factor. Now my second step to truly isolate x, which means it's sitting alone on the left-hand side of the equal sign, I must multiply both sides by 1 over a plus b, or dividing by this binomial a plus b. And when I do that, I've now created this algebraic fraction. Listing the restrictions here when you have double variables, we can discuss this more in class, but simply you would just say this: a is not allowed to equal negative b. Because if a equals negative b, then a plus b would equal 0, and therefore that would be a restricted value since the denominator cannot be 0. After you have successfully isolated the x and determined what your restricted values are, you can see by looking at the fraction, I have a factor of a plus b on top and another binomial factor of a plus b in the denominator. And when I cancel those out top to bottom, I'm simply left with x equaling a plus b. Here's number 34 from the homework. It's not arranged quite as simply as number 30 was. So in this particular problem, the way it's given initially, the x's are not gathered on the same side of the equal sign. So we need to rearrange this problem. So I'm taking the negative bx and I'm going to move it to the left-hand side of the fraction bar. And the negative 4 that's here, I'm going to move it to the other side of the equal sign. And now I have a simple trinomial for factoring, factors of 4 that sum to 5. So let's express the right-hand side in its factored form. Erase this. And now on this side, on the way to isolating the x, which means, first of all, it has to be expressed as a factor just one time. If I use my reverse distributive property on this, factoring out the x, I'm left with 4 plus b. And I'm going to stop here and let you all finish this by yourself in your homework for class next week. The last example that I would like to do in section 6.1, you can see that the instructions for this particular problem ask you to find the x value that makes the entire fraction equal 0. When the fraction itself equals 0, you're looking for values that make the numerator equal to 0. But we still have to go through all of the steps that we had to go through prior to this problem set. So the first thing to do is factor both numerator and denominator, and I've successfully done that here. Then I list my restrictions, and remember the restrictions apply only to the factors of the denominator, because you're looking for the x values that would make either one of the binomial factors equal to 0, and using the zero product property, then the entire denominator would equal 0 if only one of the factors itself equaled 0. So I've listed my restricted values. Coming out of this one, x is not allowed to equal positive 4, and coming from this binomial, x is not allowed to equal negative 2. So I've listed my restricted values. Moving on then to actually answer the question, which asks us to find the values that would make the fraction itself equal to 0. When I'm doing that, I'm looking for values that would make the numerator equal to 0. So looking at the binomial factors of the numerator, I can see that the numerator would be 0 if x is positive 4, and the numerator would be 0 if x is negative 4. Now I have to compare the values that would make the numerator equal to 0 with the values that x is not allowed to equal, the values that x is not allowed to be. And we determined in the previous slide that x is not allowed to equal positive 4 because of the binomial factor right here sitting in the denominator. That means that x equaling positive 4 is not allowed to be a solution or a value for this problem. So the only answer for this particular fraction that would make the entire fraction equal to 0 is if x itself equals negative 4. And we call the positive 4 right here, it's called an extraneous root, or an extra root. And we'll discuss this more in class next week.